Hello to this nice and frosty UK fine day. I'm joined by the legendary Paul Gerrard, and we're going to talk about all things testing, but I think fundamentals today, which is going to be quite interesting.
Yeah, thanks. Thanks for having me on the show. It is a beautiful day, but yes, it's freezing.
I think it's a -5 at the moment outside, so we'll keep things nice and frosty, and we might demystify a few testing terms as we go along, because partly is I know, Paul, you've been doing the testing glossary for probably the last year now, and kind of putting together little video snippets of explainer videos that kind of help say, well, what makes a test strategy, or what is component testing, or boundary value analysis, or equivalence partitioning, all these kind of terms that we hear within testing. And you've started kind of bringing those together into a kind of a glossary, but also onto your YouTube page. Do you want to talk a little bit about that, which, what the highlights have been, and maybe some of the challenges of simplifying it into a few minutes of video?
Yeah. Well, the background to that is, you and I have been in the business for many years, and whenever you speak to people about something like integration testing, you've no idea what their definition is compared with what your perspective might be. So there's definitely lots of room for confusion, and lots of grounds for getting confused about what people are talking about. Anyway, so the background to this is like, do we have good definitions of our terms? And there are definitions out there, but they don't always agree perfectly closely. And so I thought, let me make an attempt to bring these terms together. So have a term and then multiple definitions. So I've got one from the IEEE, I've got one from ISTQB, got one from TMAP, for example. The Dutch kind of process improvement, the Dutch test process that's very widely used there in mostly waterfall contexts, I think. And what I've tried to do is not really come up with a perfect definition, but just to explore the topic, like integration, and say, well, what is integration? And the definitions are kind of helpful, but don't get you that far, because you don't get the explanation that goes behind it. So I've tried to provide videos which give 10, 12, 15 minutes or so discussion around the topic, to try and clarify what we're talking about. It might actually confuse people. we'll see, but it's an attempt to try and clear the mists, if you like, because it's so easy. I mean, even when you talk about something as simple as a test, different people have a different perspective, a different perception of what that word means, and what's the scale of it. Is it a test could be a 200-person year effort in a massive banking system, or it could be a single button click on a screen or on a mobile. So we need to be clear. So that's the goal. I have to say, my target was to do one term a week. And I failed miserably on that, and I've taken a kind of a holiday for the last couple of months. I need to get back on it. The next one I should do is system testing, I think, which maybe I've been putting off because it's a big topic and I don't want to go into all the detail of it. I want to do it in less than 15 or 20 minutes max. So maybe that's why I've been putting it off. Anyway, I expect something in the next few weeks. I'm going to restart the whole thing soon.
Yeah, well, I think, this is the infinite question, isn't it? And I've got a blog going out this week, which dates back to my first interaction with testing back in the 90s, and it talks about a story of me taking in essence a whole test suite printed out onto physical paper, and then going into a lab and manually testing each test. And I'll talk a little bit about that later, because I think it helps us define. But a few things is first is the terms.tkbase.com. So that's terms.tkbase.com. So TKBase, if you don't know,
it's tkbase.com/terms.
Yeah, just to make that nice and easy. But
I will change it though.
But we'll change it.
Don't worry, carry on.
If you want to give it a go now, anyway. So part of it is, I think it's a great start, and I think this is the thing is, and I kind of why I wanted to take this back to basics, right? Is, we're both, hovering around that kind of, well, nearly 30 years testing landscape, and you could probably tell numerous stories around, testing. And where it all began, shall we say, about that experience that be for you. But, I wanted to kind of start with the kind of the hardest question, what is a test, and, why even test? How would you define a test and the need to test?
Well, the easy thing to do is to say that we all test as a human activity. Everybody who's kind of sentient anyway, test all the damn time. We make choices based on the outcome of some kind of test. We taste food before we commit to eating it, perhaps, or we try out a car before we purchase it, or we compare kettles, or whatever. And obviously apps and software and systems as a whole. So there's this concept, there's this notion of acceptance, that I'll accept it when I've seen evidence of it doing what I want it to do. Okay, and that's very fundamental. That's a human activity that's universal across almost everything we interact with. We test people. We interview them before we hire them. We interview them before we marry them. Whatever. So so that's all. It's all built in. Okay, as a human activity, it's absolutely up there. In our tools, if you like. Now, obviously, we're talking about software and systems and the complexity of these things, and of course, these things can go wrong. So, the way that we improve these systems as we develop them, ostensibly, we test as we develop, as we build. We need evidence that things do what we think they should do. Now, we might be coming at it from the perspective of a developer, and the developer has a mental model that says, I've got this problem to solve. I'm going to create a formula or process some data and come up with a calculation or whatever. They will test maybe from what they have in their heads, their mental models. Obviously, bigger systems have specifications that go into massive detail. And they are the source of knowledge for developers to build stuff, but also the source of knowledge for maybe system testers, people who test specifically to get through this process. They will use that spec as a basis of a lot of their testing. And it might not be, well, no requirement is perfect. We all know that. They're fallible in terms of their correctness, but they're also exhibiting or trying to explain or specify behaviors on a tiny scale compared with what the possibilities of behaviors are, particularly possible data. So anyway, what starts out as a simple thing, as a human activity, I can test a pint of milk and see whether it's gone off or not, goes to how do you test a flipping aircraft carrier, which is as complex a thing as there is on the planet, which consists of thousands of systems which themselves are terribly complex. How do you test that? How do you commission an aircraft carrier? I mean, it goes the whole gamut from testing an electric shaver, which you would have thought would be quite simple, but I'm sure isn't, up to an aircraft carrier. You've got the whole thing. So testing kind of covers all that. It's partly about the notion of acceptance at some level to make a decision. It's partly about finding bugs, because obviously testing is a great tool for finding bugs and then obviously fixing them and then retesting them to demonstrate they have been fixed. So the notion of a test is very wide. It's a very wide kind of horizon of what we get involved in, isn't it? So, and the essence of it, though, is I would say, and I can't remember the exact definition, but I picked a definition from Merriam-Webster, which is it has three variations, and I'm not rehearsed this, so this is off the top of my head. So one, it's kind of a trial. You're putting the system, the thing you're testing, and the thing that's under test, you put it on trial in some way, and that kind of makes sense. there's a judgment going to be made on it, if you like. A test can also be looked at as a kind of procedure. Now, that might be a written procedure in triplicate and bureaucratic, whatever. But very often, in order for us to do a test, we simply have to think through the steps in our mind. And so it doesn't have to be written down. You know, a test doesn't have to be written down, but often it is in some environments. And the third one is now I can't remember. It requires, I'm going to use a word I don't use very often, a perspicacious thought process. So it's a thinking problem. It's a human thinking problem to get around this challenge of getting information about the world to make a decision. And our world, you know, at this very moment might be, can we go live with the system? So we need to run some tests, get some evidence, some information, and present that in a way that makes sense to the people who want to make the decision. I would call them stakeholders often. They've got to figure out whether it's going live or not, and testing gives them most of that information. It's not always done completely in a rational way. People still go on gut feel. That's just the way things are. But what testing does, it helps people to make decisions by providing information about the behavior or non-behavior or faulty behavior of things we test. That's a very long-winded way of putting it, but it's a big subject. That's the problem we have with it. That word is very small, but it covers a massive area of human activity, dare I say, and certainly in software development activity. Most developers spend most of their time testing. You know, they write code, but the first thing they do after that is test it, or they write tests and then they write the code. Whichever way around they do it, testing is at the heart of software development. And testers spend all day thinking about testing and doing it some of the time. Users test, and when we look at a document, a spec, the old system, we test it to discover its behavior and to understand it, maybe better to understand what we should do in the new system. Testing is all pervasive. And this is what makes it very hard to pin down. So it's a big subject, and no wonder we get into difficulties.
And, you know, that's probably why we could talk about it all day. And, you know, I want to add 3 dimensions to that. I want to go the hard dimension, which is kind of, can, you know, systems be tested, you know, by, you know, other systems. And so I you know, before Christmas, I did this sentient test expert, which I kind of talked about the idea, and it's kind of derives from an idea that you had many years ago, which is the evaluation of where am I, right? You know, is a system sits there and it says, okay, I'm here, a bit like a Dungeons and Dragons. It goes, what happens if I go over here? Every time it reassesses everything that it's doing, and it uses, I'm going to use the word cognitive reckoning by those sensors that you talked about. So, you know, I'm going to say vision being a primary source for testers, but also you could add other sensors to that, right? It doesn't just have to be vision, you know. And I think there's lots of dimensions to that, but I don't want to go too far into the technical stuff straight away. But what I did want to do is I wanted to play as Postman Pat, because I used to love watching Postman Pat as growing up. And obviously, for most of our UK viewers at the moment, they'll probably be familiar with the problem with maybe the post office that's been brought to light quite recently, and at the company that I actually
tragic. It's a travesty, isn't it? It's awful. It's awful.
It is, but I think it's something worth talking about, because, you know, part of it is the company who developed the software, who actually, you know, the company I started in the 90s with was actually linked to these guys. The post office, or Postman Pat, I'm going to use the easiest thing, because then we can make it into a very simple
You might get into trouble with the creators of the children's program. It's a children's program, so
I think that's already been ruined with the Yorkshire version if you Google that. So, you know, part of it is, I think, you know, I'm Postman Pat, and using just a gherkin give a specification. You know, I want a system so that I can do, you know, I can manage my post office, and I can deal with all the, you know, payments that are going in, payments that are going out, you know, maybe do my accounting for me, deal with all the stuff that I'm taking at the till, you know, all the tracking of all the different post deliveries. You know, I think part of it is I'm asking for quite a complicated system, because the post office, in essence, if no one knows what a post office does, it predates email in the sense of delivering physical items to people's houses in those old days, right?
Yeah.
So part of it is, the question then goes, is how could it get, what happens if there's a bug in the system, and what could, and I'm going to do some spoilers quickly up at the end so everyone who's not in the UK can understand, is that we've found out in the last few weeks that actually, all these people have actually gone to jail because they've been convicted that they've been taking money out of the post office. And then we've now found out that actually this money, the system had a bug in it. So these people have actually gone to jail. There was one lady who was pregnant at the time, swore, I've not taken money out of the post office. And she had to give birth in prison. And, that level of severity that's changed people's lives. And this isn't just one person. This
I
is
think more than 10, one suicide on the back of it.
And suicides, all based on a bug in the system that's managed to go on for 10, 15 years, and updates by this vendor who built the product that have gone to enhance this product. However, someone tested that system. And this is why I want to bring this up, is that I've got a feeling the reason why we're not hearing the full story at the moment is because somebody probably accepted the testing had been successfully completed, right? Someone from the post office probably went and did, you talked about system testing, but we're talking about user acceptance testing, system integration testing. They went through many, many phases without realizing there's a fundamental problem with the system. And that could be some nuance that says on every 30 calendar days, in 1% of use cases, 10K disappears because, it's a rounding up error that someone's put in a code checking that was a mistake. And, now people have been, there's a shortfall, and these people have been convicted for taking that money out of the, of the system, which is a paper-based system. And you can say, look, there's evidence here that you've been stealing from, your employer, who's to blame? And I say who's to blame. I'm going to use the word without being a journalist for a second, is there's testing there, and this systemic testing that's happened across both the integration testing and the people who, and Nico's just come on to say, the post office miscarriage of justice, an example of what happens when software testing goes wrong, and the people who are involved, their lives are ruined by this, because this isn't just a bug which causes a problem. We've seen this in the past with other systems. This is something that's had an effect on people's life, being in prison. How do you even think about understanding the root cause analysis and where it's gone wrong? But how do you even get the decision to go live or not go live with a system like that when you've got that potential power that could potentially change people's lives? So talk me through how you test it, Paul, from day one. When that's not what I'd say. Or did you actually?
Again, perhaps just to well, firstly, let me say this: I've not followed the story closely. But this story, I do know because it was in the news, the computer papers, the computer press. Computer Weekly has done a heroic job in making this more public and trying to bring it to the attention of government, because it's a government level problem, isn't it? Because it's a government system commissioned by the government from a supplier, Fujitsu. No doubt there were other organizations and lots of, let's say, bureaucratic implications of big government systems in the mix. My understanding, so the comment from, I think, Nico said, well, software testing goes wrong. I don't know if that's the case or not. I'm not sure. I'm not sure that's the case, because it was known 15 years ago, definitely in the 2000s, the 2000s when the system went live, that there were thousands of bugs reported. I think we can only assume a lot of those bugs were reported internally, and certainly a lot of those bugs were reported by postmasters who were trying to use the system, who couldn't balance the books. But then the real tragedy about this is the computer was trusted above the human beings who were using it, because the cases that were brought against, it's in the hundreds, I don't know the number, but it's in the hundreds of people for small sums, a few £100 to tens of thousands of pounds, and some people did get convicted, whatever. The critical issue there is that the computer was trusted and the people who were defending themselves against this injustice were not. That is one huge error of organization. It's not one individual. I mean, I'm sure there are lots of individuals to blame, but it was a systemic problem in the way that project was operated. That's what went wrong, I think. Now, should it have been tested better? By all accounts, clearly. So maybe testing did go wrong, but then some things never change. Do testers ever get the time they need to do the job they think they need to do? And by and large, they don't. Testing is probably still perceived by some people, but 20 years ago, probably by more people, still perceived as something that doesn't add so much value. It's the developers who write the code who bring the money in to the supplier, not the testing they do. The testing is an overhead, and it might be regarded as such. And it's a pain in the neck. It's a difficult thing to do. So it has not a lot going for it. It's hard. It doesn't seem to justify itself during the early stages of projects. It's hard. People just crash on regardless, knowing they've got problems, but they sweep it under the carpet maybe. So where testing goes wrong is very often where people aren't given enough time. They're being asked to test systems that are untestable because they are so flawed, they are so full of bugs that you can't make good progress. Environments in those days, before virtualization, all that kind of stuff was the norm. Environments were terribly, terribly expensive, and these were processes that like it's one of these things that they weren't just selling widgets, and it was just what are the two numbers you need? You need a count and you need a price, and you can sell a widget and so on. Not at all. These people were selling things like dog licenses, TV licenses, postal orders, hundreds of different products, all of which required different data to create a transaction. And so the scope of functionality was incredibly broad. It was like building 500 e-commerce systems, not one e-commerce system. And this was before e-commerce was a thing, almost. So anyway, what went wrong, don't know, but the public inquiry that's ongoing hopefully will shed some light. But it was known the system had serious problems in the late 2000s. There's been a lot of blaming going on of whether politicians, did they act in time or did they act at all? My understanding from, I can't remember the name of the journalist now, but my understanding of the only public confirmation that there were very serious problems in the system came out in 2015, which was 15 more years since, after the project actually started. It took that long to get the information into the public domain. And there was a whistleblower who was part of the project who basically spilt the beans and said, look, there are just so many issues at stake here. Anyway, it's a mess. Is it a testing problem? Don't know.
We will find out.
Testing, but it's a human problem. It's a human, it's a failure of culture, of organization, of commercial interests. It's a human problem. I would say at heart, not a technical.
And I'm going to, add into this, and I got another LinkedIn user who's kind of mentioned HMRC and IR35. I do know that based on people who've probably met me this week have realized I had a brown letter through for self-assessment that said I owned a large number, which I could have bought a small island with. That's due by the end of the month. Now, I'm obviously kind of the opposite. I'm kind of like, my previous role was working at HMRC. I know all the systems there. I could probably go, well, hopefully it's a system rounding error. But, part of it is, to me, I think my first stage in all of these is challenge, right? Challenge the system, and I think that might be a different viewpoint as a tester than maybe some, the general public. A lot of us haven't got confidence in things like HMRC because we've overpaid tax or we've underpaid tax and they've not got it right. They've got issues wrong. We know it's an incredibly complicated system, death and taxes. We're not going to go into it because it could just go on forever. But, part of it is we know these systems are complicated. And in a way, we know they're flawed, right? And we know, even things like IR35 and I'm not going to say Gary Lineker. Well, I might have already have done there, but where there'll be people who will take advantage of process in a slightly different way, and people are he obviously went to court and it was not found guilty.
I mean, without naming names, it's not the individuals who are to blame. It's the accountants who know the loopholes.
Oh yeah.
Here's a wheeze that's borderline legal, but we can get away with it because the systems allow it. Therefore,
that's the thing, isn't it? It's the systems of systems, right?
It's almost like the computer is right to our advantage, but it's wrong.
Exactly, and I think that's the thing is we're asking it at numerous different levels, right? We're talking about ethics, which is really hard, right? In the sense of, in a way, slightly the bias, right, associated with the of these systems, and then there's also the fact that there's these kind of loopholes. If I was a postmaster, I would have been, questioning it, but then I think also based on my position, I would have been thinking, well, actually, if it's only $30 or $30. I would have, just topped it back up thinking, oh, it's slippage or something else. And part of it is maybe not talked about the process. But I want to bring something else really easy. And, Nico kind of said that he completely...
I think open that kind of worms are going to move swiftly on. But just to round it off, is government IT historically has been, I wouldn't say an unmitigated disaster, but it's on the spectrum. It's way up there. I mean, I've worked on at least 3 systems that, well, one, I wish I could name, it's all public, fire control. I worked on that, started working on that in 2004, part-time, but did a lot of work over 7 years, and then it was cancelled. The reasons for that were very complex, but one of them was the users didn't want it. The stakeholder didn't want it. They couldn't find any stakeholder who said, this is a good idea. And that's a very, very big simplification. But how do we get into this situation? Well, it's a human problem. It's a communication problem. It's a lack of knowledge and the hierarchies problem. Anyway, we
this is exactly what I wanted to kind of talk about, because it's kind of what this links into. Requirements engineering a little bit, which I kind of wanted to talk about. Where does the requirement come from, and how do you then say to it, this is not a good requirement, right? If someone says, build this fire, control system, at what point do you challenge it to the point of saying, well, actually, this isn't good. This isn't the right thing to build. And I'm going to sidestep that quickly, but then go to the opposite end of delivery models, right? Because now I'm kind of in the matrix kind of ways. I don't see software delivery lifecycle methodologies anymore. I can't agree or disagree with, I believe in engineering practices, and when people wrap them around in post-agile or agile or, some other methodology, they're just talking about speed of the multimodal delivery mechanisms. And so, part of it is there's different failure rates, right? You could say fail fast is not the 7 years working on a project and then it fails and it never goes live. Yes, that was a mistake of doing these huge, requirements up front and, planning projects that are going to be there for 5, 6, 7 years. We can see why they failed, but then we can also see this opposite side of things, which is, and I'm going to just go back, taking the post office example, users are reporting issues, right? And, this is where I kind of have a challenge with current software development practices, because if I'm on the dog and bone or the phone, ringing them up and raising an issue saying, oh, the system won't add up, right? And, I'm a user. I'm not a specialist accountant. I'm just telling them what I'm seeing. This information then goes into, I'm going to say ServiceNow, but it could be any kind of incident management system. Yeah. And then, of course, they start tallying up. And at some point in time, somebody within IT service management, and I'm going to use the word, the way that I see software development, which is you've got your application delivery life cycles over here, and then you've got your IT service management stuff over here, which is kind of running the actual systems that have been delivered by these companies over at this unit over here. Never shall the two meet. You very rarely see a software team that then moves it into production and then manages it. They might say that's DevOps and that's kind of the way that we do things now. But I think they're a lot smaller scale. If you think of a government system, you might find that one incumbent will create the software, and then there'll be a separate unit, maybe the same company, but they're not the same people who are running the system. At what point does the knowledge change from these people over here who built the system, who know the system really well, and these people are reading, in essence, incident tickets going, well, that's a low priority, that's a low priority, that's a low priority. Oh, that's really important. We need to change it. And then, and this then links back to, I'm going to call it the business, because, I loved a quote which Gartner said, I think it was the last century, said, there'll be no more IT projects. You won't have IT as a cost center. It will be just the business, right? And I still think, we'll all be, it may be partially in agreement that this entity, which is information technology division, which is not very good at managing information and questionable about technology sometimes, exists on its own right, and that actually it's segmented away from the business. And we may try and bring the business in, but in actual fact, I wouldn't say we're the most successful at doing that. And that if you are a business, let's say the post office with postmasters, how involved are they within the SDLC? In the same way, the people making the decisions about how the system should work, how close are those to being postmans, right? Or postmasters. So, this is why I want to bring the fundamental problem up around people, because I think this is where we keep on talking about. These aren't technology problems. These are people problems, which we've kind of said many times. Where does the requirement come from? Because, if I'm talking idealization, right, who is it who decides to even build this system in the first place?
Yeah.
And should they be accountable?
I don't know how many issues you've just lifted up, lifted the lid on. But one of them was, you said, well, how do service management organizations communicate with development teams to get things fixed? Well, it's it's a human problem, and the systems that are in place are, it's the old story of putting the plan that we used to put man on the moon and scaling that down to build a teapot. I think that was the kind of the joke of the time, that we don't need such complex systems to get relatively simple messages from A to B, and the message comes from a user in production, through ultimately to a developer who's got to fix the problem. One of the problems is, like, my partner actually works for the NHS and complains about the systems that she has to use, and she's sort of muttering under her breath, and I say, well, what's wrong? And she'll say something like, well, there are 4 systems dealing with this relatively simple thing. It's to do with immunization and task management, let's say. Okay. Has someone given permission or approved that their child gets a jab? Yes or no? And then, have they had it? Yes or no? You'd think, well, there's 2 Booleans there, and they're all both yes, no's. And the complication is, it seems to take multiple systems to get unreliable data on whether this is being done correctly. Now, that is so, we shouldn't knock government systems, because banks and insurance companies and manufacturers, whatever, all have issues of their own. It's not just government, although government is just such a public failure very often. Anyway, so how do you get information from A to B in the chain? It's a complete mystery. That's the problem, and the views of users might be, you might have a group of 10 people in an office saying, oh, this bloody system, oh, I'm going to report this. And then someone will say, oh, we've all reported that. Nothing ever happens. It never gets fixed. Blah, 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 blah. In the meantime, it doesn't get reported and isn't given the prominence it should. So someone at the other end says it's a low priority bug, and yet it's driving thousands of people mad. Those thousands of people they don't have the power to get their paying across to, because the service management company is probably not part of the NHS or the civil service at all. It's outsourced, and they're paid on results, and the results are number of bugs processed. High level, probably priority, high severity bug reports fixed. But if they're getting the severity algorithm wrong, whatever it happens to be, and they get paid on basis of numbers, we all know, paying people on the basis of number of bugs they report is not a good incentive, because people invent bugs and they report bugs multiple times, and they'll find things that are completely trivial that don't need fixing as bugs. And so it's we don't do that. Testers don't get rewarded in that way, but companies who are in the chain of command do get rewarded that way, which undermines everything that we as we teach testing. It undermines everything we hold dear. That's not how it should be done, and yet big companies are making billions out of this kind of game. Anyway, we move on. So you talked about requirements.
Yeah.
Well, have you ever met a tester who said, "Yeah, I've got fantastic requirements"? No, not very. Well, maybe the odd one, but very few. If I came to you and said, "Give me a requirement for creating a system to do A, B, C," you'd scratch your head and say, "Well, what's the requirement?" Now, you've seen requirements and you know more than most people. But if you ask a non-IT person to define the requirements for a piece of functionality to do their job, which might be order processing or managing taxi drivers in their business, out there in the field, taking fares, or processing tax. If you're not an IT person, you don't have a first idea what a requirement looks like. You can say, well, this is what I want it to do. I want it to do all this stuff. Oh, by the way, here's a book of rules which define the processing. So electricity pricing, it's operated through a market, I believe. So you have the generators creating electricity, and the distributors, the regional electricity companies, basically distribute that electricity, but they bid ahead of time for electricity energy at a certain price. It's a market, and it's just like the stock market in some ways. It's very fluid and dynamic, and politics and world events affect the price of electricity, and so on and so forth. And if the FA Cup final, used to be the FA Cup final, was the busiest, the half time on the FA Cup final was the busiest or the most demanding energy surge in the UK, because everybody got up and made a cup of tea, didn't they? That's literally what happened. And so the requirement for looking at peak, I'm going off on one, but I'll come back. So I said, well, how do you manage things like this? I said, well, how do you plan, or how do you forecast energy and demand? And they said, well, we use the Radio Times. They literally look at the TV schedule, and in the gaps, that's where people make cups of tea when there's a big energy peak, or stuff like the King's coronation or royal weddings and massive events. That was all part of the planning. Anyway, how do you define the requirements for a trading system, which is what the electricity business?
So let me add on to that, just to make.
I saw the requirements, and it was, I can't remember how many pages, but it was that thick, maybe an inch or two thick, of mathematics. It was all formulas, and it was all written by PhDs, PhD engineers, whatever. And this is how, and they got it working, and that's how it worked. Absolutely fine. So they had requirements that were pretty damn good, but that was simple. Although it was immensely complex, that was simple because it was simply a whole batch of formula that got strung together to come up with a number which said buy or sell or whatever. Anyway, I digress. If you're trying to model a human system, people don't know how to do that. And what a developer would say is, give me a mathematically perfect definition of what the software should do, which then puts the developer out of business because they can press a button and generate code from it. But anyway, that's neither here nor there. What they want are perfect requirements. but they never get them because humans aren't capable of writing perfect requirements, because we use a language called English or Swahili or Russian or Chinese, whatever, which is a natural language. And that's for communicating human events almost, and art and literature and all that kind of good stuff. It's not very good at communicating formal logic. You need formal logic for that. But how many people understand formal logic in the business that you're asking to define a requirement? Zero.
Well,
That's my problem.
Let me add a few things onto that.
And it all. So anyway, so to just close off. So requirements are fallible and incomplete. We all know that. That's just the way it is with humans, And so what a software development project is about is, it used to be thought we could get a perfect requirement and wind the handle and go through a series of stages, waterfall, and end up with a system. And we knew it didn't work. So we built all these kind of compensatory processes like change management and bug reporting and so on and so forth, and testing was built into all this kind of stuff, configuration management, all these other things which compensated for the fact we didn't have perfect requirements, and we're going to have a lot of change. Very expensive, often delivered crap, So then we went to Agile. No, I don't want to say that. I've lost my thread now. Then we kind of went to Agile and kind of said, let's just talk to each other. I know what I was going to say now. So in Agile, rather than have these processes where people communicate through documents at a very large scale, we just sit down and have a chat, or we stand up and have a chat, on a daily basis. And we're always in touch, and we're always hearing what all the rest of the team are doing. On a small project or a small team, that's viable. What is a software project? It is a learning project. And the essence of it is the end product is code, which is the knowledge, which is trusted to some degree. And the process of getting there is a learning process which evolved. Our knowledge evolves from very fundamental stuff that is probably wrong through to all the detail and complications that come out as you learn what the system should really, really do. And we haven't got processes that manage that. We haven't got processes that manage that process well enough. Waterfall is a problem. Agile is limited. You can't do everything with Agile. You can't build big systems with Agile in the way that, because it's not Agile anymore. It becomes a factory process, and we know that doesn't work. It probably has worked once or twice in a very small number of places, but 99% of projects don't work that way. Yeah, are we still? So it's a cultural, human, logistical problem. Sure. It's an emotional thing. It's got commercial pressures which hide information. People don't share information because of commercial interests. And people lie because they don't want the system, but they've got to give you a requirement. So, would I give you a good requirement if my job is going to disappear and I'm going to be fired at the end of it? I'm not going to give you a good requirement, am I? I'm not incented to do it well. I don't want to be the turkey that votes for Christmas. So we put ourselves in all these terrible situations that build systems that simply don't work, and would never work. So that's a very depressing state of affairs, and that's why we've all got jobs, basically.
Well, no, I love it, and I think requirements engineering is close to my heart, right? And I know we've talked about factory models before and software factory models. Toyota, Kanban, Lean, taking in essence a methodology which is used for manufacturing of goods and applying it to software development, where really the synergies aren't really close. Is obviously kind of inevitable. And then I think you've also highlighted the human factor, right? I think I'm not going to say trustworthiness of humans, but we've talked a lot about it being human-based problems, people being the problem, right? And and then we've talked about, well, just introduce a change management or a service management solution, and therefore the people aren't the problem anymore because it's a system. And then we've kind of then said, but these systems are misused and it maybe don't fit one size fits all. So maybe you don't need an IT incident management lifecycle process when you're a 3-person startup, right? So, I think part of it is we talk a lot about scale, and then, we could go back to Tom Gilb and Eric Simmons and talk about language and requirements definition, bring Dot in from up the road from where you are now and talk about document inspection. You could go back to those glory days of kind of, looking at it. And I did install literally, which
don't
is my
take
last
glory days and imply that the systems were better then. We've got the same problems now as we've always had. We get a bit better every year, but not much. Yeah.
And so I just literally loaded up the last app I installed on my machine is a Windows 3.11 app, which still running 16 bits, so it doesn't actually launch, which is the automated requirements measurement tool, nicely named ARM, by NASA, right, from the Software Assurance Technology Center. And I was talking to somebody from NASA the other day. I'm going to do a session with him in a couple of weeks, and part of it is you take that and you think, okay, and that was great. Look at ambiguity in language, all the stuff that we're talking about. That language is great for poetry, not great for defining software. We're still in that same part, and I know we're going to move into models in a minute, but part of it is, I wanted to add back into your kind of scenario, right? So we talk about the power demand and power systems. I was on a similar project for the Startwerke for Germany, where they use virtual power stations, right? And so use the word virtual, and straight away we're talking software-defined networks, whatever. But the concept of no Homer Simpson there with a button at a nuclear power station, virtual power stations, what does that really mean? And it's talking about exactly what you said, a trading-based system. The difference was they would be able to buy and sell within a 15-minute window electricity. And the demand response generation was based on not the radio times, but it was based on predictive weather algorithms that would look at how much the grid would be generating out, because it was mainly solar and wind. So it'd tell you, based on the forecast, it's -5 or whatever at the moment. It would understand, based on what the prediction of the weather is, how much generation is going to be done, how much surplus they're going to have. And then the demand response algorithm, in essence, was taking in, buying and selling of, it up 24 hours ahead, but also within the 15-minute windows. And then what you would get, in essence, is, and this was a proper legitimate use case, would be you'd get an air conditioning unit managing its green, when to buy electricity, buy and sell electricity by its own, by itself, as a kind of a connected device. Is, you would say, well, actually, I only want to buy, I only want green energy, and I want to be able to buy at this level. And again, very complex systems which required a lot of, and I'm going to use the word ML on there, and algorithms to work all that predictive capability out. And then we're in a post world of, unfortunately, AI-based infused systems. That makes testing even more complex. But I also wanted to kind of add in is the explainability aspect, because I think partly what we're saying is we're all speaking different languages. It's great if you're speaking, maths to somebody who understands maths, and it's great if you're using Klingon because it's a maths-based language, which is unambiguous. If everyone understands Klingon, is that we've all got disciplines with all different, terminology that's specific to us, but then also domain and language that's associated with that, right? And I know the last time we did the live stream, James Bark replied back saying, around the context-driven camp side of things, and partly I think part of the model for testing, which we'll talk about in a minute, is sources of knowledge, right? Is that I can expect that a business analyst who maybe traditionally was Prince 2 certified practitioner level might be doing some kind of ITIL v4 kind of methodology in the back of their mind, is meeting somebody who's a traditional software developer, and you may be a tester, an IS2QB tester who's gone down that particular route, all using very different terminology. And then there's the organizational layer that sits on top, which has, again, acronyms for ARM being Automated Requirements Measurement Tool for NASA. NASA must have thousands of systems, subsystems, terminologies that overlap to every term that we've talked about today. And then you've got to sit on top of that and know either software assurance, business, and business management or business analyst kind of camp, you can kind of see why all of these people mixed in together and doing a daily stand-up and communicating in a proprietary language of English would get confused and misinterpret requirements. And then you multiply that into those, I'm going to call them squads, because otherwise you can't be doing shape or some kind of post-agile methodology. Those squads are hundreds of squads, all that don't talk to each other because they're individual pods, and they're literally all dependent to do and I know your topic next, system integration. They're all part of systems of systems. How can they possibly build pyramids, right? It's just impossible. It feels like we've already set ourselves up to fail. So what do we do, right? Is it a new model for testing?
It's impossible. Now, Paul, what do we do? Yeah. My observation would be this. If you look at, we've all heard stories of the military, of planes falling out the sky and rockets hitting the plane that launched it, and ships that get lost. Or wasn't there a story of a ship that was controlled by Windows NT computers, and they all crashed at the same time, and the boat was just stuck in the water, couldn't start the engines, couldn't navigate, all the communications with, and so on and so forth. It was just a hulk in the sea. Anyway, whatever. So we've all read about these things. The good thing about building terribly complex software that interacts with the physical world, let's put it that way. So a radar guided missile, or a satellite that needs to go and transmit radio messages around the world, or take photographs, as a spy satellite, whatever. Or software that controls a crane, or software that's used to analyze the elements in a very large bridge with thousands of elements all interacting to support, 1 million cars a day over a big span, whatever. These are all interacting with the physical world, and the physical world obeys the laws of physics. That's what's good about it. And so that you can always say, how would this work in reality? So the example I would use is, for a period, I was a civil engineer, not for a very long period, I have to say. And I got involved in computing almost instantly. But anyway, one of the systems that was used there used a thing called the finite element method, which is a way of analyzing structures. And at the time, the company was responsible for reviewing the situation of the Severn Bridge, the then Severn Bridge, the old one, whether it was safe, whether they should build another lane or close it or do whatever was required, because it was aging, obviously. And if you imagine, the thing about finite element analysis is you break your complex structure into the cables that support the platform, the towers. I think I've just lost you.
No, I'm still here.
Sorry, just something just took my screen away. Yeah, I'm back there. So if you there are 1,000 elements. There are cables, there are concrete decking, there's the towers, there's the huge cables, the catenary cable. See, I'm trying to throw in as many buzzwords as I can. Whatever. And you can analyze them. You can break it. You can analyze it to the point where you're just looking at individual elements. Now, the thing about the individual elements is, I can't remember the number of forces. There are forces in 3 directions. There are also rotational forces, and so on, and I can't remember how many there are when you add them all up. There's a lot. Let's say it's 12. I don't know. It's probably more than that. That they must all add up. Otherwise, they must all add to 0. Otherwise, that element would just fly off. Okay, because it would have an unbalanced force. So in space, it would just move, wouldn't it? So you've got that foundation that if those forces in your calculations don't add up, you've got a problem. It's so bloody obvious, and you can't argue with it because it's the laws of physics, right? So that's the good thing about engineering software, is you can create immensely complex software, but you've got this absolute foundation, this non-negotiable and non-negotiable requirement, but also that requirement can be tested because you can do it in a lab. You can do it in a lab. You can build a physical model and test it and so on and so forth. You do all sorts of things. And that's what's wonderful about engineering, is you can get really close to very complex problems without really understanding them and write software because you've got the reality to compare against. In a human system, you haven't got any of that. And that's a massive difference between software that controls, let's say, machinery, as opposed to a human process. And so, now what can we do? Well, I think the engineers on the side of working with laws of physics are fine. They need help, but they don't need much help. They do a pretty damn good job, I think, all in all, because they're in a safer world, even though it's often a high integrity arena. So engineering practices work because they're dealing with laws of physics. Fantastic. What about the middle of the road IT folk like you and me? We're completely at sea, and at the mercy of events and human nature, and so we have to compensate for that. Communication is probably the single biggest challenge we've got. So communication has to be a massive part of it. And having communicated, and we talked about the Horizon system, the post office system that went terribly wrong and is a continuing saga and tragedy, I suspect people found bugs and reported bugs, but they simply weren't acted on. Now, whether they were reported well or not is not the issue, but the volume of problems and the fact that people were being taken to court on the basis of a computer system that was faulty and being trusted as it was faulty, that is a human problem. And so we have to compensate. The biggest single thing you could say is critical thinking was not applied. And it was not applied, but then not used. You know what I mean? So the output of critical thinking was not used. So people could say, you know what, we should look closely at these 10,000 bugs we've got on the register. Are these people really being shafted because the software does not work? Or is it because we are a big government organization? We have the power to take people to court and always win. Maybe, it's a human problem. So testers, I think, have part of their responsibility is to think more carefully about situations, whether the situation is a requirement that seems flawed, and you can demonstrate that through example and say, I've got 2 examples of this system in use, and they come up with different outcomes because the requirements are ambiguous. That's a problem. Absolutely right there. What does a programmer do? Does he write code to say, well, depending on it's a Wednesday, Thursday, Friday, do this, Monday, Tuesday, and Sunday, do that? Is that what they do? Or do they say, you know what, I can't write code to do this. It's unmeetable, this requirement, because it's inconsistent. And so testers have a responsibility for looking at the inputs to testing, which are the system, plus all the knowledge required to understand what it should do, and as the basis of how you test it. Now, some of that knowledge is written down, but a lot of it, you could say most of it, is not written down. And so testers have a duty to discover as much information as they can through talking to people, through reading documents, looking at the old system, talking to users, all that other good stuff. So testing is much more. The basis of testing is very simple, but the act of getting the information you need in order to perform a test that has meaning is terribly complex. That's the problem. And at the heart of testing, and that is a communication, and it's also a belief system that actually finding faults in things is a good thing. Now, some suppliers would say, well, yeah, if you can find what you like, but let's not tell the customer. That is a commercial choice that's made. It's an ethical choice, you could say. And so, I think we are in the realm of, if we're going to get better, we need to have a lot more, this is simplistic, I know, critical thinking. We need to take the output from that seriously and act on it when it's appropriate, and share our knowledge across commercial boundaries. That would solve an awful lot of problems in the government sector, and the regular commercial sector. But I think it's less of a problem. I mean, people are less, less loyal in some ways, and so this information does find a way of getting out. So, like, for example, the space shuttle disaster, was it the first one? Was that the Challenger? I forget which one is which. I think it was a Challenger. Let's say it's the Challenger that blew up a minute or two after takeoff when it powered up, and the whole getting Richard Feynman involved as a physicist who knew nothing about rocket science. Well, he knew the mathematics, I'm sure, but not much else. They had to get him in, and they had to feed him information for him to come to a conclusion and do a demonstration with an ice cold glass of water and the O-ring, and saying when you put it in water at minus whatever degrees in a clamp and you unclamp it, it doesn't bounce back. It doesn't go back to its original shape, and that could be the cause of the leak. Blah 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 blah. NASA knew that, but couldn't bring themselves to say it. That's what big organizations get themselves into real difficulties.
And so I think, jumping onto that, moving a little bit onto the
we are jumping around quite a lot.
We are jumping around, but no, this is all good. And it's kind of, I kind of wanted to talk a little bit about a new model for testing, which isn't a new model, because it's, probably 10 years old now, but I call it V2 because, it's partly, trying to think about how it's evolved over time, and also kind of picking on kind of Nico's kind of question that he kind of came in, is that of how to fully leverage knowledge between teams, exactly this, right? And I think the example which you're talking about, from my understanding, is they'd literally told before the launch, these guys had already said to them, this will happen, and then they still launched it anyway. And it was, in essence, I keep on hearing something what you're saying about it's our kind of duty of care to be able to report and articulate this concisely, but also to the level of urgency that's required. And sometimes I think that's quite hard, because we do get tunnel vision, and we could quite easily say this is really important based on our beliefs.
They literally, the engineers literally came up with the chances of failure of being 1 in 200. And you think, well, that doesn't sound too bad. But this was in a program where they were going to launch 200 shuttles or something, a big number, a large number. And so you're trusting, you're playing Russian roulette. The failure is almost certainly going to, if you've done your calculations realistically, and they denied it. They said 1 in 200 that's fine. That's fine. They didn't think it through, or they chose not to think it through, or there was a group think. They were told not to think too carefully. I don't know the full details, but as an organisation, they suppressed that knowledge, and a failure occurred, and there was no surprise after it when they figured out how it happened.
But anyway. I think this is the chain effect, right? Is in a way we're talking about lots of multiple groups that maybe don't always talk to each other, that all have a risk mitigation plan for 1 in 10, 1 in 50, and that in isolation they seem, okay. But then once you add all these different elements, they, the likelihood is probably 70%, right? Failure, whatever that reasonable amount. And we've seen this, and but I think taking this back to software for a second, I think is kind of two things. What I find really interesting in it, back into the kind of the new model for testing thing, is like, sources of knowledge, right? We've talked a little bit about how we communicate, but also what information we use to our kind of in our arsenal around how the system should work, the axioms that are associated with different dimensions and how they're proved out. But what I'm trying to say is around this whole inquiry and challenging first component, right? Is what I give an example with Dorothy is actually brought Dorothy in to do some of with the MIT project for during COVID, right? And she was phenomenal because she was just going through these really smart MIT guys' documentation, and she was kind of finding faults with the requirements, saying, well, this doesn't make sense, and literally kind of going into it for quite a lot of detail. How I would say, very similar to the document inspection book, very valuable, but we don't
just having someone independent who is not blinded by the same assumptions that the authors had. That's the reason you don't test your own software, is the assumptions you make going into that process to build stuff you then take into testing, and so you make assumptions that make you blindside you. You know, that just sort of make you think that's not worth testing because it's so simple. You know, You know, how could it fail? It's one line of, you know, and so on. And you're blind to problems that someone else would come along and say, no, I'm going to test everything, so that's fair game. Oh, blow me, it doesn't work. You know, and people are just blind to these things. You know.
They are, and I think this is the interesting thing, because I think you added something which I've not really thought about too much, right? In the sense of, you know, can you raise, in essence, a defect against a requirement, right? And you know, this is, you know, I know the answer is yes, but, you know, part of it is I typically wouldn't have ever done that, in the sense of I wouldn't have taken a requirement level thing which says, you know, on Monday, Tuesday, Wednesday, the system should do this, and the rest of the week, except Sunday, should do that, right? Yeah. And, you know, I might take that in some kind of formalized Gherkin acceptance test driven development, and I might have some, you know, acceptance criteria with the axioms of, you know, it for every other Tuesday, this is not, you know, it should not happen, you know, and all this kind of these examples of, you know, executable specifications that I could work my way through and challenge, right? And what I could in theory do is I could create a model of, based on what the picture of the requirement that you're drawing, plus the sources of knowledge that I know about the system under test, I can draw a picture of saying, well, this will not work, right? Because what happens if it's a leap year and, you know, X, Y, Z, right? You know, I might throw 5 or 6 things at it, which are saying, which they may refine within the documentation and the requirements specification, and catch things earlier than when it actually happens in the system, when they start, you know, going further into the SDLC. And I think, you know, part of this, and I'm kind of, this is where I'm kind of breaking through the barrier a little bit, is we're talking about shift left. I think shift left really focuses on SDLC. You know, it focuses on, you know, earlier in the life cycle, you catch an issue, it costs less, right, to resolve, right? That's the notorious kind of thing. And maybe there's some value in that, but, you know, I kind of punch that through to say, well, you know, it's much further than that. It's all the way to idealization, right? If someone's coming up with an idea, that idea is to create widget X, you know, that if that idea isn't being defined, then they, to the level of rigor that it needs to be. And yeah, if it's a very simple system, you might say, well, it's not necessary. If it's the, you know, the healthcare example you gave, which was, have they, you know, have they consented to vaccination? Have they been vaccinated? Right? You know, you would say that you could argue that you could define that in a few requirements, and that actually I could model that using some kind of modeling technique, and it would be an incredibly simple system. But then when you add in 7 or 8 different entry points of different systems and where the question could be asked, you know, let's just, for argument's sake, it's NHS Direct and it's on your mobile app, which is your local, you know, your local GP, could take that data and then have to put that into an overnight batch, which then passes it to your local hospital, which then updates the flag that says you've been vaccinated. But the problem is it does that every day at 5 o'clock, and that actually I go from the GP straight to the hospital, and the hospital haven't received that flag. So therefore they then vaccinate me again, and I'm, you know, none the wiser, right? You know, part of it is there's always systems and systems dependencies. So does a model help? And that's the kind of the first question, because it starts as a shared understanding of how we think the system should exist, and then we can overlay that level of knowledge and information that should allow us to provide a hypothesis.
Well, just to say where models come in. So when you look at your source of information, whether it's requirements or the old system or interviewing people or whatever you're getting your information from, things get complicated pretty quick. And you might capture things on the basis of in a model and write it down. But by and large, most testers, these documents already exist, perhaps, and this knowledge already exists. They have to build a mental model. And the mental model simplifies the complexity of a very large system, but the model is sophisticated enough for you to make predictions. That is, if I enter A, B, C into this screen, I should get D, E, F coming out, whatever the situation is. And if you like, what a tester does is read as much or learn as much and talk to people as much as required to get an understanding sufficient for them to make predictions about what the software should do in certain circumstances. At which point they can start speculating on all these weird and wonderful things that you could try to make the system fail, which could occur in reality, but no one's thought about to put it into a requirement. So the tester adds value by inventing all these scenarios that are possible or could be possible. They might be very unlikely, but they're still possible, and to add them to the mix of things you should try. Now, what happens in that process? Let me just say, when you say you build a mental model, you could replace that text, build a mental model, with build your understanding. When you think you understand what the system should do, you're ready to do some testing. Now, I'm not saying that's complete at any time. Things are always fallible, but you've got to make a start at some point, and you've got to make a judgment about, do I know enough to do something useful, testing related? Now, what happens as you build that model is you start seeing anomalies, because there might be, to trivialize it, there might be add a customer, update a customer, why no delete customer in the requirements? Does that ever occur? And the guy who, or the person who wrote the requirement might say, oh yeah, that happens, but it's really rare. Well, it still needs to accommodate that, because someone's going to come to the point where they want to delete a customer, and if the feature's not there, that's a problem. So the tester can avoid problems by thinking through a requirement from the perspective of reality. Imagining the system is there, what might happen. And there are lots of little tricks and techniques for doing that. And Doc and co with the inspection process can create, an input to the inspection process is a set of rules which allow you to try things out, if you like. Now, the rules might be grammatical rules for sure, but they might also be, one rule might be, if you encounter a term that has no definition in the glossary, stop and report that as a bug. There must be a definition of every term we use. And yet, how many times have we picked up requirements and there is no glossary? So everybody has to interpret what adding a customer actually means. And people will make different assumptions. Assume makes an ass of you and me. That's human experience. That's what happens. But the trick with building your mental model is you spot problems, but also when you get to the point where you can make predictions about what the system should do based on your knowledge, you can start adding examples which challenge the requirement. Because if you have an ambiguous requirement and you have in your head, well, if I do ABC, that should produce DEF. But if I put ABCD in a different order, I get XYZ out. Is that possible? So no one said the order in which you add the data, is significant in the requirement. But the tester might invent a requirement because it's a possibility in the real world. And when they do that, the user writing the requirement might say, oh, the user would never do that. Well, it's possible though, isn't it? So what would happen? Oh, it would be getting wrong, because if you answer the first A, if A is greater than 100, pieces of data B and C are not required, or the calculation, the formula changes, or whatever. And if you've ever been involved in an insurance premium kind of calculator, and they're all online now, when you add all these pieces of data and you do the comparison sites, that kind of stuff, depending on how you enter the data, you get a different outcome. So the software needs to control that and behave correctly. So if you change a piece of data that is no required, well, surely it should be blanked out. That's a new requirement for the tester. Now, if the tester gets the software without that requirement implemented, they're going to say, look, I can just watch me make it fail. And what a tester is really doing by reporting a faulty requirement is to say, in about a month's time or 6 months' time, or whenever this is going to be delivered to me, I'm going to try this. It's going to fail because the requirement says you carry on and do whatever the hell you like. And then I'm going to report a bug, and the developer's going to have to go back to square one and figure out what the requirement really ought to be. So you're saving, some bugs are so trivial to fix. Yeah, of course, there's not this escalating cost of a bug, through their life cycle. Yeah, some bugs are cheap to fix whenever you find them and fix them. Some bugs, though, are so severe or severe in their impact on other functionality in a system that they can trigger all sorts of other misconceptions which lead to faulty software. So you want to avoid that. For finding bugs early at requirement stage is always a good idea. I mean, there's no argument against it, in my way. Now, don't get me wrong. Building a prototype, you might say, we're going to cut corners and just build a minimum viable product. We know it's not finished. That's an experiment, and that's fine. But one of the outcomes of the experiment would be to learn the things that you really do need to specify correctly. And that's why you build a prototype. So it's a learning exercise. It's part of a learning exercise to understand what requirements should really, really be. Anyway, I don't know if that answers any question you put to me, but
it does, and it fits the standard two, the two loop backs. If models are not adequate by default, and you have to, they add value.
They're all limited.
They're all limited, right?
But you asked about when something goes into the field, and the users use it differently than it was anticipated in the lab, if that makes sense. I mean, that's exactly what happened with the fire brigade system, you could say, because the same system had to deal with dispatchers. I'm not sure what they were called, but I think they were called controllers, but they dispatched fire appliances to events, to situations, fires, whatever, usually. Central London has a completely different set of requirements to rural Wiltshire, where there's a handful of farms spread over a large distance. It's not like an urban environment at all. And yet the requirements to deliver the service are the same. So of course they have different problems. I do recall part of one of a system in that sphere was there was a big dependency on the radio systems being delivered. It was all mobile radio. And it worked fine, but not perfectly in Norfolk, which is a very, very flat part of the country. And yet the same system was going to be deployed in Wales with mountains and a Lake District and Scotland and so on and da-da-da-da-da. Okay. You think, well, hold on. Has anyone thought this through? Why are they saying it's acceptable not having tested it in a mountainous area? And this was a kind of I think it was apocryphal, but you know what I mean? People do that. And even NASA had the issue of, was it the Mars orbiter, which was launched to Mars to map Mars, I guess. It went into orbit, went behind Mars, the dark side of Mars, and then was never heard of again. And they traced it back to the Americans using imperial units and the Europeans, because it was a joint effort, and the Europeans using metric system. They weren't even using the same bloody units. And that was an integration problem, but it's an integration of the teams. So when you see an integration problem in software, it usually reflects a communication problem in your team. And I discovered that, donkeys years ago. It's because people don't talk to each other. They think it's not important enough to have that conversation, or I haven't got the time, or whatever. And these are human problems that directly affect the quality of software.
Yeah, and just onto that, I kind of, I wanted to talk a little bit about, I guess, about ways of working, right? And I think you've just kind of said it there around, a lot of what we're talking about here is human-based problems and communication, right? And to me, that's kind of the biggest flaw anyway. Humans, we're flawed. We make mistakes. That's just human nature, right? We can't do anything about that, right? It's kind of, but it does.
But we can think about it better, but maybe we can't. It's a logistical problem. If you want to talk about the model, let me move into that space now.
Yeah, no. I do, but I kind of want to just add one thing that you said, which is, and I've observed it because we've been building a new platform. Which was originally called the Synthetic Domain Expert. The idea was it was going to be a bit like the context-driven camp. It was supposed to. It knows. I used the easiest example. Where Neo says, "I know Kung Fu," is it knows testing. But at the same time, we know what happened next with Neo. Is he then had to fight Morpheus, and he's got his ass kicked because yes, he knew the principles and of kung fu, but he didn't know how to apply them into to a certain level of mastery that you've got. And this is this same thing which I kind of want to talk about, and it's kind of where the model kind of kicks in, is around information. And we talked about it briefly, but information just being dots of data, right? And then knowledge being the overlap on top of that around the joining of that information to give it contextual and awareness and understanding of that information to turn it into knowledge. You could then also then wrap around it again, Yoda, Morpheus, wisdom, your knowledge of, well, you've seen this system 50 times, you know the kind of Dave Snowden kind of view of complicated, complex, you've seen these patterns before, you can't expect it. You could think of Dr. Emma Langdon and people like system thinking, and you kind of go back round to these kind of things of big complicated systems, but we treat it at a smaller scale. And so when we talk about modes of communication and we talk about requirements and how things are written down, things aren't written down, you could argue, and like we have a stand-up every day at 3 o'clock, part of it is someone will say wait a second, that needs an extra input, and it's been communicated. 5 people in your squad or whatever have now all understood and agreed that's the way to do it. Maybe nothing's been written down, but that knowledge now is in the heads of those people, and it's not in any model. It's not been formalized, but it's in a transcript within Teams because you've just had that call, right? And to me, that is also a source of knowledge, right? And people are making decisions, sometimes the wrong decisions, and there's a lack of traceability. There's a lack of traceability on how the model's changing, because the model's ever evolving based on discussions and the evolution of a model continuously, and requirements traceability, I could partially say is the infinite problem. Is this triangle, which I kind of class as kind of requirements to tests to code kind of triangle, the normal triangle, is things are continuously changing. I'm communicating with you on this call, you're a developer, you're making the quick changes at the back end. I'm also communicating with my product owner, or and they're communicating with somebody else, and things are moving continuously around, and everything needs to keep in sync. And then someone needs to say, well, why was this decision made? Who made this decision that the system should do X or Y? And you could probably bury it out of some transcript or some communication or some Slack message or some ping or some coffee break conversation that we had. But things are a lot more difficult than they probably were back in the days of a requirement. And this is why I'm keen to talk about the model side of things, is because I do feel that the principles of a model means, and this is where, a lot of people will, probably find it quite difficult. It's like, I give this example, and I want to utilize your brain for a second here, because I think you'll appreciate it as well. This example is, so what's your favorite app? Well, actually, I'll give you my favorite. I'm just going to pick an app on my phone, which I've not used for a while, and make it a bit more legitimate. But, I'm going to give, okay, I don't know if you remember back in the day, well, actually a TV guide, we talked about it earlier, right? I've got a TV guide app on my phone, right? How does that work, right? Tell me the model of what that application does. What's the flow? How does it work?
You want me to tell you?
Yeah. I want to know what the model is for that application, right? Because it's probably
emulating what used to be in the Radio Times, where it's just program listings in a chronological order across multiple channels. The BBC had several TV channels, and so that would be put in a columnar format. And so it's kind of just giving you almost like a calendar, I beg your pardon, of events at various times during the day, with occasional asterisked comments saying timings may vary because this is a live event. And like last night, Blackpool played Nottingham Forest, and you got like it's an example, Premiership team playing a Division 1 team, which is 2 divisions below. in the FA Cup, a replay. So Blackpool did really well, and they forced extra time, and if they'd still been even, then it would have been a shootout. At any rate, Blackpool lost in the end, but that went on a good 40 minutes longer than scheduled because they had extra time again, and there was a lot of extra time in the regular time as well. So they actually played nearly 2 hours, before, no, more than 2 hours. It was 100 and, I worked it out, but it was, I can't remember now what the numbers were. Anyway, so there are exceptions to the rule that says this is the running order. So I guess it should do that too. It should allow for, it should recognize live events and other events that are dependent on the real world, because news happens. Quite often you get news bulletins that are emergencies, the tragedy of Gaza and all that kind of stuff coming up as a news flash. And that used to push everything out of kilter, didn't it? And programs got cancelled as well. So it's got to deal with that in some way. So if it's a live online, it's a live document. It's not fixed in time, do once and forget. It's not like that. It's a news item as opposed to a catalogue that doesn't change from month to month. Now, I'm not giving you any requirements except set the scene, but what the requirements are is give me a program listing. That's all it is, really.
And that's the whole point is, and obviously it might have impacted me watching Traitors or whatever it was, what was on next. Part of it is we know how these systems work, right? And you could partially argue, rightly or wrongly, is if I fed in the help file, let's say there is a help file or some guide or some whatever it is, or maybe some documentation on how they built it, then I could tell you how that application works. I could kind of explain that, when it launches, I'm probably going to accept some terms and conditions, that's saying that this isn't right, completely right, 100%. Otherwise, you hold them liable or whatever. And then you might have to select which country you're in, or it might even, take the location off your phone. We could guess and build an image model of this. And we could then get down to your point of view of saying, well, actually, let's now run an edge scenario of a live game, which is going to throw out the schedule. We would expect that maybe the RSS feed or the back end system that's pushing the TV guide can do that, so people can say, "Oh, now this is going to be your favorite TV program's no longer on." We understand that, and you're not a specialist, or hopefully not a specialist in the TV production world. But the point is, we can build a model of that. We could kind of already know what the screens would look like. We don't need to launch the application. And this is my question about requirements: is that if I'm in a TV company, or I'm in a fire brigade system, I can apply my context and knowledge around a domain, and I can assume, we've already said it's probably not the best of idea, but I could model my knowledge of how I would expect the system to work, and then I could pick literally the system up and look at it and go, well, that's completely different, right? Actually, it's not in any kind of sensible order. Now it's and it's not breaks for the electricity grid to go up. It is literally it's streaming services that can watch on-demand content whenever you want, Netflix, say, right? But now it's more focused on what's live today, what's dropped today, combined with live TV and maybe some other hybrid, right? But our assumptions could have been wrong, right? Something could be completely different about the format. It could be crowdsourced based on social analytics, saying that actually we're hearing, like we're live streaming now, that a new model for testing is the most popular thing, and now suddenly it's showing you all the previous videos that you've been booked about this, right? And just to add that to the list, if you go to the bit.ly link, a new model for testing, you can watch Paul talk about the model for testing. It could be that, right? It could come up with your video because it's the biggest trending item, and it's more now about Gen Z, Gen Alpha, who want to consume data in smaller TikTok format kind of things instead of an hour and 30 minutes of us talking about it, right? But the thing is, and this is why I want us to move on the model now, is that I believe you can do the model as early as the requirement definition or the idealization, and you can prove against the hypothesis the more and more the system evolves. But it is important that not only is it a mental model, it's a shared understanding of a model, because otherwise my view of the TV guide, Gen Z, I'm not Gen Z, but and your baby boomer version might be completely different, right? So how do you, why is modeling important?
How to solve these intractable problems.
That's why you're here, right?
So I'm an advocate of using modeling. Now, what does that mean? I wouldn't say, so model-based testing is not a choice. Okay, so I think the point I would want to make about this is you don't have a choice as to whether you model requirements in order to understand how a system should work. And as I suggested earlier, when you model a requirement, that is your understanding of the requirement. You build mental models, and that is your understanding. The model is your understanding. Now, your mental model in your head that no one else can see inside of, unless you can't do it, right? And you're quite right. Another person reading the same requirement might build a different mental model. And typically, there's a kind of a challenge with developers building one mental model because they just want to get on and write code, and testers building a different mental model because they're looking for faults in the requirement to look for anomalies and to challenge it. So it's a different perspective. So you have different perspectives or different perceptions of what the system should do. And of course, as you just said a minute ago, what we really need is a shared model that everyone buys into and says, yeah, you know what, your understanding is the same as my understanding. And then you don't have the problem of communications in the same way. At least it would help communications because you've got a shared model you can talk about and talk around and debate, discuss, challenge, and change, And that's the problem. So I'm not saying we should use models. You're using models now. You're just not sharing them in a very good way. And so this notion of modeling is about building shared models. Now, okay, that's ancient history. We've known about this. This is what engineers have been doing for thousands of years. When you write a plan for a project, that's a model of reality, of your prediction of how reality is going to pan out. When you make a drawing of a building you're going to build, that is a model of the building, because it's really expensive to build the building and then say, right, now what we're going to do is build it we're going to make it do what we want after you've built it. No, you can't do that. You've got to build the model first and then you build the building. So engineers have known about this for donkey's years, and software engineering and the theorists and the academics, jumped on this very quickly, very reasonably, to say, can we apply engineering principles in the same way and build models? And so, and UML was kind of, I want to say pinnacle, but that makes it sound like the problem has been solved. It's not. It didn't solve a lot. UML came along 25 years ago or so, and there are, I don't know, I lost count. I mean, 12 or 14 different model types, sequence diagrams, entity relationship models. What did I just say? Collaboration diagrams, flow charts. I haven't looked at UML for donkey's years now, but they had about 12 different ways of constructing models of systems, use cases, system use cases, user business use cases, different levels, some kind of user journeys in effect, and so on and so forth. All this kind of good stuff. State transition models or state models. Okay, so UML came along, and then the first thing the IT community did was like, right, what we need are tools to capture these models, and so we built all this computer-aided software engineering technology to capture these bloody models. And then we had models coming out of our ears, none of which kind of integrated very well, even though we knew in principle you can transform a collaboration diagram, which is about messaging between agents to deliver some objective, and a flowchart or swim lanes, whatever. You can transform one into the other, okay? But of course, people didn't do that because they said, well, we're going to put all our eggs in one basket in this model and deliver on the basis of these three different views, like a state model, an object model, and a collaboration diagram, maybe. I don't know. They cherry-picked what they did. And the people who put these models together didn't talk, so they ended up with models that didn't agree, and software that had lots of ambiguities built in based on which way the wind was blowing. So the problem with that approach is it's really expensive to build document models. That's the problem. It's really hard to justify putting documentation like that together unless you're working in a safety critical, high integrity kind of arena where the budgets for that kind of activity are very high. You've got, it's assumed you're going to do this. Go to the middle of the road IT stuff. That's a big overhead. The documentation is a massive overhead, and that's the challenge we've got. Now, my argument, probably about 10 years ago, maybe a bit less than that, was I think the models that testers build have value independently of documentation and hearsay and stuff on whiteboards and meetings and the existing system and whatever else are your sources. The models that testers build, I think, should be shared across testing and then used to present their situation. And so the model might be something as simple as a hierarchy of features, and each feature has input data and output data, and maybe some relationships. Maybe you capture that as text, just say whatever. And then as you explore a system, you build up this picture of features that can be exercised in sequence, and the paths through the system as you go through the system can be captured in this model, which is growing organically as testers explore the software. And I built a prototype of this, and I wanted to make it as easy as possible to use. So I thought I'll try and build in, make it voice activated. So I cobbled together some very poor quality code, I have to say, to use, I think, Google, voice to text kind of software. And then Amazon put out Alexa and all that kind of stuff. And I made some progress with that as well. But then, of course, first thing you have to do then is like, oh shit, I've got to create a domain specific language for testers to speak to get the data from their heads and their fingers into this, and so on and so forth. Anyway, I think it's still theoretically possible to do that, by the way. But you capture the pass through systems as people go through those systems. Now nowadays you might say you don't use a voice, you just have a monitor which tracks people's behavior and so on and so forth. But the model evolves over time, and that's of the system as built, not a model of the requirements. But where am I going with this? The value of a model is if it's shared, you can have discussions and debates about its completeness, its accuracy, its ambiguity, all that kind of good stuff. Because that's a model you're going to use. Your understanding is going to be used to create tests, whether you write them down or not. And my argument with the new model idea is I don't care whether you write tests down or not. I don't care whether you run them using tools or not. I don't care what industry you're in. I don't care, and so on and so forth. And that's literally how I presented it, that it's not relevant to the way you think, because the patterns of thinking are what matter. And you've got to be thinking in a sensible way, a systematic way to get from A to B. And there are feedback loops where you go back one step because this requirement isn't good enough, or this test tells me it's more complicated than I thought, and certainly more complicated than the requirements said it would be, because the developers obviously had to think about a different problem and create some code to do X, Y, Z. And like, ooh, that's nowhere in the requirement. It's one of these things, knock-on effects that the users never thought of. But the thought process of getting from a source of knowledge, a requirement, let's call it, through to modeling the requirements, creating tests, running tests, interpreting results, whatever, right through to the end where ultimately you hope your test pass and so on. The thinking patterns, I think, are consistent across all testers. And we should understand those better before we commit to buying a tool to run tests or manage test cases or to document tests at all. And so, the model to me, the new model for testing, it's a model of testing, not a model of a system or a requirement. Its value is it separates all the clutter that confuses us, all the technology, all the process, all the bureaucracy, all the tools, all the different ways of capturing a requirement, whether it's narrative text or stories or what's the cucumber thing? Gherkin language. I don't care how you do that, because ultimately you're going to end up with a model over the requirement. So, what I've tried to do with the new model is to separate, to me, the things that clutter up your thinking from the thinking, if that makes sense. And to me, it answers lots of questions. So in terms of its value, I call running a test on the model, it's called, oh God, you've got me here. Running a test, what do I call that? Applying the test, right. So I call it applying the test. Now, I don't care whether you apply the test by hand or whether you use a tool or whether you use some of the piece of, Vulcan mind magic, whatever, mind meld or whatever, I don't care, not relevant. It's a mechanical activity in some respects. But what that tells you straight away is test execution tools fit into that very particular area of your thinking. It has no relevance to any of the other thought processes, and there are 10 altogether. So the tools that dominate the vendor tool industry are test execution tools still, and they only cover 1/10 of the thinking that we really need support with. Test management tools manage test cases, which is like, well, if I don't write test cases down, why would I need a test management tool? If I can do it on a whiteboard or I can do it in Excel, I don't care whether you do it using a grandiose test management tool or Excel or a whiteboard. I really don't care. That's not relevant to the thought process. And that's my argument, that get back to the thought process and then you really know what you're doing and where you're having problems.
And I think that's where I kind of wanted us to get to, right? And it's kind of where my head is at the moment in a number of different ways. So, I'll do the exec version because it's probably shorter. Is I kind of start. I've been doing automation now for 25 years, and 25 years plus, and I kind of, I probably don't spend my time saying, "Oh, automation is the way forwards," right? Part of it is, I'm very much. I've gone through the different levels of maturity, and I understand that. They add value into the process, and of course, probably the last 5-10 years, I went from kind of grid tools, doing model-based testing, a lot of the Dick Bender kind of stuff of, okay, let's look at it pairwise, let's do all these kind of, approaches, and then, I've definitely seen, especially over the last 2, 3, 4 years, I've seen where modeling works, where it doesn't work, in pure MBT landscape. And when I think of MBT, and then representations of it, things like XPDL and business process modeling notation from like a UML perspective, kind of, a way of trying to structure it down, is I've seen the challenges of large adoption in organizational wide, I'm going to call it modeling, enterprise modeling for a second, but, again, not everyone's critical thinkers, not everyone's suitable to do model-based testing, and also models are a massive investment, right? And they, continuously change. Yeah. So, and I've seen it succeed and I've seen it fail. And then I've also seen the opposite emergence of people doing smaller scale models, because, complex systems, complex models, your model could go on forever, right? At what level of abstraction? So I'm going to move all that to a side. And kind of get you to where I'm kind of currently thinking. And it kind of gets into that 10 dimensions you've just been talking about, is that, I could probably look at, I'm going to call it session-based testing, but it's not the correct term is, but I could see a day in the life of a tester. And you're right, you've been talking about this idea of this integrated test environment, what kind of help could you give me through different stages of my thinking, of my exploratory kind of, my daily activities, what could be helpful at different stages. And that I completely agree. And it's kind of the stuff what I actually put together on a slide yesterday, which I was trying to quantify, which is that actually, if I was going to talk about test execution, and this is purely manual or automated, I'd put it as a very small percentage of the time, maybe 10, 15, 20%. And what we're trying to do with automation tools and execution, self-healing capabilities, is where we're trying to save time, in which is a very small amount of time anyway. Now, you could also argue that, retesting, maintenance, again, are painful, because in essence it's reinvestments in time for things that don't add any new value, and therefore that 15-20% still is very painful. But you could also say that everything you've just talked about is that the real value of testing is the activity of testing, of going through the thought process. That, and I'm calling this test design, is that actually test design is probably the bit which we could get the most benefit from tools, but we haven't really unlocked yet, because tools aren't that smart enough to help with that, right? And I say that in the sense of,
tools. I mean, in terms of modeling, tools need to be better than pencil and paper or a whiteboard.
Yeah,
and they're not. They're just not as easy to get going, if you know what I mean. And that's anyway. Sorry, I interrupted.
Yeah. No, it's fine. And and this is why I think, like I talked about the information and knowledge and this, I think it's also changed, right? And so, like, what we're doing at the moment, we're using, I think we've talked about it quite a bit anyway previously, but we're using RAG-based architectures for graph neural nets, right? And part of that view is that actually a model isn't enough, is that actually it's a model plus, in the sense of, models, we use digital twin definition language, which is again another UML derivative OMG kind of standard, but it's like any knowledge graph, is it has the relationship of information to other information. So, what does this application look like in Norfolk versus what it would look like in Wales? Part of it is that's an element which is location, and we can build up our questioning and reasoning around that, right? And we can find information that may be relevant to help us think about testing it more completely. And the example that I always give, just because it's an easy example, is is taking in some really heavy requirements from an automotive company, which actually I went to visit last week in Coventry. But part of it is that, as an example, is if they're feeding me a whole stack of braking specifications, which are only a small part of the overall car and function, these specifications, it can create a model for, right? And it can start adding in axioms of speed, temperature. Let's just take weather, because weather's the conversation outside. And it could say, well, cold, well, what do you mean by cold? Or you might say ice, what do you mean by ice, right? And places like Portland at the moment are posting things around these extreme temperature fluctuations, where you may say ice and braking in ice, but you could say there's 9 degrees of these icy conditions plus rain and other components that could have a knock-on effect, right? And we talk about testing being a normal activity. We would drive up to where you are at the moment, but if I drive my car, the first thing I probably do would be test my brakes, because are they okay?
Will it go up a hill with an incline, an icy hill, with an incline greater than about 3 degrees? Is it a rear-wheel drive?
All my cars are rear-wheel drive. So, part of it is braking conditions, temperature, all these different components. And the first thing it did was try and say that actually, rain, there's 6 different types of rain, right? This to the point where the road, the actual compound of, and back to your kind of scientific viewpoint, the compound of what is making up the road is now just water, and you're going to aquaplane. Part of it is there's different conditions, and therefore there should be different thresholds for acceptance, right? It should break within a certain distance under these conditions, but a bit of light rain, which is just the UK every day, compared to terrestrial downflow force and also other conditions, how should that make the tolerances change?
But I think to chip in the AI buzzword, let's say, is that's where AI will have a massive effect. I mean, I don't think AI is going to design test cases so much as it could well give us a much better source of test ideas of things we could consider, because it's got the capability of looking at things from this kind of global perspective, because it knows everything. If you give it everything in terms of data, it knows everything and can give you combinations and permutations you might never have thought of. So, for example, a self-driving car designed in the Northern Hemisphere, might work wonderfully in, let's say, the well-organized cities of Oslo, and I wouldn't put London in that category, but you know what I mean, of relatively advanced societies. And I don't want to be offensive to other societies, but can you imagine a self-driving car in Bangalore? No, because the behavior of the pedestrians, the people on bikes, on motorbikes, in lorries, trucks, buses, it looks, for all intents and purposes, like complete madness, chaos,
Organized chaos.
People get from A to B, and there aren't so many accidents, but there are a hell of a lot of accidents,
I think
that's because it's a different environment than the environment that people who are building this stuff are working in. So, and there's the old story, just to throw another one in, is I don't know which jet it was, one of the F-16s or whatever it was. It was built and tested in the Northern Hemisphere, and the first time it flew across the equator, it just flipped over 180 degrees. I'm trying to do that, but I don't know if I'm on the screen or not. Anyway, because it was built and tested in the Northern Hemisphere, no one thought that it would be an issue, and so some developer made a mistake that was completely undetected until that moment. Now, it might be apocryphal. I don't know if it's a true story or not, but it's a good story because it sounds like it could be true.
But they did it with the F-17.
AI knows about that kind of stuff. Like, what are the 1,000 parameters that could affect the behavior of your system? And it knows about them all. It's going to be much more imaginative than a human being.
Yeah.
No matter how brilliant a human being is, we don't have the capacity to do that. And that's where it could be of real help. However, I wouldn't trust it to run those tests and to interpret.
Oh, no. But the execution is not that important, right? But the thinking stage is, right? And I think this is that, the example, I mentioned the F-1117, right? We all know most expensive stealth fighter works flawlessly in the desert, but as soon as it's rain, you can see it on the radar. Part of it is you would assume at some point in time, someone who wasn't in Area 51 or whatever was, thinking maybe we should test it in other weather conditions. But, part of it is, again, this kind of, with our blinkers on, is that, we could go back all day long to testing practices, right? And we could say, is this requirement testable, right? We could go on there. And I think, and I'm not going to use the word laziness because I'm probably doing our industry a disservice. But, if we always went back to square one on every single component and went through the same rigor of every single axiom, we could get to the point where when we're having to communicate, other people they'd just get exhausted with us. They'd literally just be sat there going, I'm not interested in your non-functional requirement for, spike testing a scenario of everyone checking the box at the same time to say they've had their injection. I genuinely don't think we're going to ever have 100 million people on the NHS website all filling in this form, right? And we've seen this to its apparent, the opposite side of things, in the sense of G-Cloud and the government digital manifesto said, oh, let's do this whole open source fail fast. And we know one of the most famous examples was the petition website, whereas actually once, I think it was Brexit, the petitioning website came up and it crashed within 5 minutes. And they literally said, well, we'd done the petition.beta or whatever, and we cobbled it together with some open source solutions. It wasn't enterprise scale.
Yeah.
But then there was this loss of confidence within the industry because people were like, well, we've got the petition website back up, but we've had to kill all the results off. And then somebody started hitting it with false Brexit, just directly at the API, just making submitted random email addresses that it made up. And then they couldn't believe it because it was not, secure, another non-functional requirement. And then they brought the entire system down, and it was like the 8th reboot. And people who genuinely wanted to, vote to get it into Parliament had just given up because they'd already voted 6 times and they had to bin the results. So part of it is, I think, being able to get confidence of the solution which you're building to a level where you're able to ask the intelligent questions, but then also, you walking into, let's just say, the stealth technology department at Area 51 in Nevada, you probably be like, well, I don't know all of this color, these different specifications for camouflage and stealth technology. I could learn it, which could be a 5-10 year kind of learning curve, or I could have this domain knowledge being passed over and augmented to me as in real time. And we joked about it when we're at I think it was the BCS or another event this year, and we kind of said, well, this could be, heads up glasses where it's telling you information, augmenting your intelligence to kind of, say to you, well, these are the questions you should be asking about the 999 standard for, radio frequency jamming protocol thing, is because you just don't have the questions that have done. And maybe there's an augmented intelligence component where I just use the word, AI, but I really mean in kind of these in machine learning techniques that could augment this information to you in a format that is in more of a just in time. I'm looking at this API, what data could I do? And then it's going through thinking, well, what negative data, what would be my happy payload versus something which would put the system into more of a more of a challenge. And so I think there is a future there. And I think potentially the test design element, or that test, I'm going to call it the test, what to your point, the test thinking process, could be helped by an assistant. I'm not going to call it Clippy or Eggy at this point in time, even though we know Microsoft have already put in Copilot into Windows 12. We know they're going to turn it into a virtual assistant. So you are doomed to have a 1996 rebirth of Clippy at some point this year.
Well, I think you can turn it off. I don't mind.
Well, do you want to turn it off? That's the point. Is we've got this human complex that we believe that maybe we know everything about the project we're on, or we understand everything about the industry we're in. Part of this is maybe the simple things like the one we talked about with the post office. It was something that was so blindingly, it would only happen if we had production data, and it would only be 1% of that production data, which we never had in our environment because everything was happy, data. That is why we got in this mess in the first place. And I think the credibility of our industry is at question whenever these things happen. And I'm going to say that, I'm saying this in a very controversial way to line two things up, is we've kind of skirted around a knowledge, a model for testing in the last 2 hours. But, we've also kind of got to this point of saying that actually we need to come back to engineering practices. We need to start trusting testing as test engineering, as a discipline. We need to be able to share sources of knowledge between disciplines, between things. We need to have better definitions and understandings of terms, techniques, things that are valuable to share with our community, which is kind of what we've always been advocates for. I know, this year the big announcement is going to be around the Test Engineering Society, which I know you've been working on quite heavily, and with a larger community now of fellows who are really interested in how do we get move this discipline on. How do we share that knowledge? How do we help peers to help define, these things and move our discipline on in an engineering kind of way? Do you feel that that's really the next step? Is that we need to go back to some engineering principles combined with some modern techniques, and bring everything into line with other engineering.
Okay, I'll come to that in a minute. I think going back to the new model idea, and because I threw the AI thing, the hand grenade in, and you got into test Clippy or whatever the hell it ends up looking like. If we're going to use AI, what is AI? It's augmented intelligence, but it augments our thinking activities. So in order to make the best use of tools that augment our thinking activities, we need to understand what our thinking activities actually are. And that's the benefit of what I've called the new model. Okay, so it's not so new, but if you understand that the point in my thinking process that I'm at is here, what would give me the biggest benefit? Do I need an Excel lookalike tool to capture test cases? No, that's not what I want. And yet that's what we get, And so, I'm without going any further on that one, you can see why I'm pushing it as a way to understanding AI a bit better and where it might fit and where I don't think it has any role to play. I mean, I think we can figure that out easily. Anyway, should we go back to engineering practices? Well, I think we have. I don't know if it's going back to engineering practices, because I make an argument that you can't do engineering unless your foundation are the laws of physics, and software does not obey the laws of physics. So we haven't got that foundation. So I think we have to invent new engineering practices, not rely on, if you like, drawing office type techniques for capturing models. That's not the way it's going to happen, So in a way, the first conversation, I mean, so again, speculating, the first, and this is where AI might help, is from the very first conversation that we have about a concept. We want that text captured. We want AI to formulate and summarize it in some way, in its own way, which we might not recognize or understand until it presents it to us, to actually capture every conversation in our projects. And from that, tell us what the model looks like today. And as conversations change, that model evolves, that would be cool. And so we don't actually involve ourselves in building the model of requirements. We let AI take that task off our hands. Now that would be cool, wouldn't it? You know what I mean? Because we eliminate the human communication problem, because the AI would say, Paul had a chat with Jonathan and said this, but Tom, Dick, Harry, and Hilda had another conversation, and that's in conflict. Now, we didn't know what that conversation was about compared with what we were talking about. But if AI is listening in, now this is where it gets a bit spooky. If it's listening, AI can tell you there's a conflict, there's a schism in the project where the architects are having a conversation where the developers are saying that can't be built. And they're not talking to each other because they don't realize. And so nothing happens until the developers get the spec and they say, you can't build that, or we'll try and we'll fail because they believe it can't be, and so on. So what you want AI to be doing is it's a bit Big Brother like, but you want it to be beneficial rather than a controlling thing. But I think that's where there's some possibility of progress. Now that is completely speculative right now, but I think that'll take another 20 years to get to, maybe. I don't know. Maybe it's probably going to happen in 2 weeks. I don't know. But I think that would be a lovely concept. You don't think?
Yeah, well, that's
who looks after you, not controls you.
That's kind of what we're trying to do, right? And that was the whole synthetic domain expert, is the person who's listening to help support you. There was something we did on a stand-up yesterday where, there was a source of knowledge which had been fed into the system, and part of it is this system was actually a government-based military system, and the document that came in was not part of the project, and it had a definition in there of something which was contradicting a definition somewhere else within another document, and it was something really simple. It was PA, and it literally was PO, purchase order, right? And it should have never been there. And it asked us to define it. It literally said, look, this is kind of not, my understanding of this is, this particular product or military term, and I've found something that's contradicting it. This document doesn't feel like it's got the right context to the rest of these documents. And it kind of, it knew that. Now I know that doesn't sound thing, but partly when you said with dots kind of in document inspection, is that we should be asking questions all the way through, right? We should be kind of, asking, based on terms, definitions, whatever they are, we should be, interpreting them and understanding them to a certain point.
But potentially that's where AI can do a better job than we could. Because
we can't read every document.
We're not asking AI to answer the questions. We're asking AI to ask them.
Yeah.
And that's the easy bit. But to have a knowledge of what questions are appropriate is the knowledge that we need to that's the expert system kind of game, so
exactly. And I think this is where, again, and I think it kind of links back into the model and moving into the engineering thing. Is I completely agree. I love engineering, right, as a discipline, but I completely agree. Is the discipline is probably, when we think of it and we think of the IEEE, the Institute of Electronic Engineers, it's electric. It's what my dad did all his life, right? But it was an electrical engineer based on the laws of physics, and I think, when we applied this to test engineering, this is maybe patterns and which we've not even thought about defining, right? And that actually these things might go, it might go in many different directions. I think, we're not looking at the past and saying this is the blueprint for the future. We're actually saying the processes and thing will evolve and change, and that actually it's the shared knowledge and understanding of approaches and techniques that are continuously evolving, and how we go through that thought process, right? And that might be, we go all the way back to the start around system testing, might be our definition around system testing and integration testing versus unit testing, or it's that shared understanding of the terminology, but also the patterns that associate that and what those modern patterns look like. And then also, I think the complexity of the domains that we're in, the challenges that we have, and maybe, just the evolution of testing in general. And I think that is a community-based shared responsibility, and I think that's where I see kind of the test engineering society benefiting, is that peers can help drive things that maybe are emerging areas, things that are site reliability, things that are maybe there's new roles for us to play. And I'm really interested. Obviously, I think we're probably not going to be able to talk too much about the test engineering society now, but I do think that's the next generation is kind of leaving that legacy of thought processes and patterns that have worked in the past and may not be suitable, and questioning some of the core principles, right? I think that's just in nature how we're supposed to be. So it is very exciting. But I also think it is nice to be to have that structure around an industry that we've maybe not had in the past, right? Is other industries, chartered surveyors and stuff, they've had very formalized disciplines and things that can that they have, educational structures that go through. I think we're still in this position where how many degrees can you go into which are testing focus only? I know people like Dr. Tarek King have done, PhDs and stuff in this area, but, as a discipline, testing is probably the poor child in comparison to other, disciplines in the software development life cycle.
I think with regards to the society and getting that off the ground, what the biggest well, I'm going to say the biggest challenge, although I don't think it is if we figure it out right, is how do we define what testers should know as a, quote, standard or as a definition of what they should have in their heads, and not get into quite vicious fistfights about waterfall versus structured testing versus exploratory tools versus doing it manually or whatever labels, and processes and process wars, let's call it. I think the only solution to that, and to remain a broad church, to give everybody an opportunity to be part of it and to value and to get value out of it, is to take all that away, because all that's as I said earlier, it's all logistics. It just gets in the way. So the conversations we should have with professional engineers to judge whether they are any good at what they do is to not talk about logistics. That's all detail that just gets in the way of understanding how people think. And it's how they think that actually allows them to make progress in this game. Now, there are people who might deny that, but then I think that's a really foolish position to take. You're basically saying you don't it's a purely mechanical process. You don't have to think. That's not true, clearly. On the other hand, it's also you're thinking, but you're not using a model or a process. Of course you are. You're just not writing it down. You're following a systematic process in your head that you a very, very well-traveled sequence of thoughts, of thinking. So, I think the only way we make progress with the society to make it a broad church, open to everybody, without these process wars and, this tribal activity that's dogged us somewhat over the last 30 years, is to stick to things that are absolutely fundamental, that you can't live without, axiomatic, dare I say, So stuff about, who are your stakeholders? You must have one, because and you might be your own stakeholder, but you need to understand that relationship in order to deliver the information that these stakeholders need to do whatever they need to do, usually to make a decision. You need to understand the concept of modeling. You need to understand the concept of coverage. You need to understand the concept of of negotiating how much testing is enough. You need to understand the concept of risk. Now, these are not things that are in debate. What I mean is, most testers would recognize, oh yeah, I don't call it that, but I definitely do that at some point in my thinking. Absolutely. Well, we need them to be able to articulate how they think, to understand whether they know what they're doing, and it sounds rather academic, but I don't think it's academic so much as it's just a pragmatic way of making progress, So, without going in, I mean, I could talk for that for hours as well, but maybe that's another session.
Yeah, no, I think it's a good kind of place to kind of bring to a conclusion. It's interesting because I'm looking at my next call, and it's with a CTO of a large crowdsourcing, well, probably the largest crowdsourcing company, and part of it is. It was something you said earlier, and it's kind of stuck with me around, and this is the thing. If you're a company, let's just take Facebook as an example, or Meta, or whatever they call themselves this week. You want to bring crowd testing in. What you're doing is you're connecting into that intelligence, right? That pool of different testers who think, and you test in completely different ways, right? And in a way you might not be saying to them, you must follow some kind of exploratory testing methodology, or you must formalize your documentation of how you test. They're just testing, right? And they might be from all walks of life, cultural backgrounds, nationalities. And that's what you want crowd testers to be, right? You want, age, gender, it doesn't matter. It's partly you want a mixture of everyone's strengths, weaknesses, to evaluate.
The things about testing is the diversity aspect, and I don't mean social diversity. I mean the diversity of thinking, the diversity of tests, approaches, perception of risk, environments, from their location, the whole gamut of stuff that combines to give you a thorough coverage against some model. That's what diversity means in that context, So
no, absolutely. And I'm doing a talk. My next talk is at Unicom, actually, in Manchester, and it's around neurodiversity and why it's important for testing, right? And I'm doing it with a colleague from the BCS, and part of it is you're looking at it thinking, emotional state plays a component, right? You're stressed. If we go back to the post office example, you don't have much time. You're angry. You've got emotional things going on. You're going to use the system in a different way, but also you add the different neurodiversity traits, ADHD. All sorts of got the t-shirts. But part of it is you add all those elements in, and you're going to interact with the system in a completely different way. And this is the whole point: is it's not a physics thing. As soon as it's a human-based system, there's all of these dimensions that you add to it. And I think that's what we're looking at. Is we're looking at a new model for testing, is maybe capturing some of those activities that we go through in what makes us unique and makes testers, and crowd testers, why you'd want 500 completely unique testers who are all going to think and test in a different way. And you probably find will test your system in completely different ways. However, I think part of it is how do you understand all the components that you said? Risk, coverage, when's enough? What kind of how long do I need to test for? All these questions I still think are where we use our judgment and our experience, our wisdom, or whatever we end up throwing it in there to say, that system can get deployed into the post office, or who are those stakeholders that approve that should get to that point? And I think these are all questions, and I think, we're trying to open up that, community to find answers, to delve deeper into the dimensions and of modern test practices. And, on that, I'm going to kind of leave it as a high level of, I think maybe, that's the next talk we'll probably try and do. This was really capturing that, that there is a beautiful mind behind all of that. And, and things are complex, right? And even the basic, most fundamental questions of, should I test this or should I not test this? Or is that requirement correct? Or is it flawed? And is what we're doing flawed? And is it a problem with, a communication problem? Is it a human-based problem? Or is it a process problem? All of these questions you could debate forever, but it does show that testing as a discipline is complex. And we need that. Everyone needs support and guidance around how we test better.
I think historically, I mean, this has just occurred to me. Historically, testing was code centric or developer centric, and then testers came along and established themselves as a proper role with an activity and so there's tester-centric perception, and then of course we test on behalf of people, users, architects, and developers too, and so on. But then there's also risk-centric or whatever, and so it makes me think that actually the way we should look at testing is not as, for example, a whole set of functional versus non-functional requirements, but rather look at things through the eyes of these various stakeholders, so stakeholder centric, which I think gets you a long way, but it has to be a bit more sophisticated than that. And how do we sort of not get bogged down in, well, yeah, we're just into the infinite number of tests that we can never usefully perform, or economically perform. But I'm interested in how we think more than how we do things, if that makes sense. And I think also how we think is affected by our interactions with other people, and how AI might be able to help is if it can get a handle on these interactions, that would move us along a little bit more, I think. I'll have a think about that. I think there's a talk in there somewhere.
All right, that's what we like to see. Well, on that bombshell, we're going to end it an hour and 20 minutes. It might be a new record, which I'm sure we'll try to dice into testtalks.com and everything else. But yeah, I think we've set some foundations, and thanks for the people who'd added questions in there throughout that session. Hopefully it was some value for you. As I mentioned, the bit.ly link of a new model for testing, all one word, if we'll re-divert you to Paul's talk. But of course, thanks for tuning in. And obviously, when we get some additional questions on the stream afterwards, we'll try and address those in following sessions. But thank you so much, Paul, and
thank you.
Thanks for the new model for testing.
Thanks for letting me talk about it.